Welcome back to Aurora Tech Channel. Today, I'm going to review the BambuLab A2l. I received this machine at the end of April, and the video was originally ready right before the official release date. However, I also wanted to test the official firmware, and the results turned out to be pretty different from what I had seen with the beta firmware. Because of that, I decided to postpone the video, rerun several tests, and re-edit the review before releasing it a few days later. As a result, all the tests and results you see in this video are based on the official firmware. With that said, let's take a look at what the A2l has to offer. Compared to the A1, the print volume is more than doubled. The A2l has a build volume of 330 by 320 by 325 millimeters. If you use the AMS Lite stand and place it on the table, the full setup requires almost 800 by 920 millimeters of space, assuming you leave enough room for the moving bed and the bed cable. The required height clearance is also around 800 millimeters, so it takes up much more space than a Core XY machine with a similar print volume. However, you do have the option to print a top mount for the AMS Lite to save some table space. The trade-off is that the total height clearance increases to over 1.1 meters. It is still a bed slinger, so with a tall bed slinger we would normally expect to see some surface quality issues as the print gets taller. However, the A2l uses multiple point input shaper calibration. It stores several sets of values at different Z heights as well as different X and Y positions to provide more comprehensive vibration compensation. The motion system is similar to the A1 with a linear rail on the X-axis, steel wheels on the Y-axis, and linear rods on the Z-axis. The tall gantry also comes with 2 support arms, and there are 2 granular dampers at the top corners of the frame to help dissipate vibration. The maximum nozzle temperature is 300 degrees, but the bed only reaches 80 degrees compared to 100 degrees on the A1. There is also a new sensor on the nozzle wiper that can detect nozzle clumping. The print head has a few important updates as well. The A2l's extruder now uses a servo motor instead of the A1 stepper motor, allowing for more precise filament control and improved feedback during operation. And the filament buffer is built directly on top of the tool head, much closer to the extruder. This allows the system to retract filament more precisely and more aggressively before cutting, leaving less filament inside the nozzle. As a result, each color change requires less purging, which helps reduce filament waste and shorten the total print time. This is not the same as the long retraction when cut option in developer mode. Instead, it takes a more hardware-based approach to reducing filament waste. Another major difference compared to the A1 is that the A2l supports a blade and pen module, allowing it to cut paper, vinyl, leather, and other thin materials. With permanent markers installed on the pen module, it can also draw on almost any surface. I would like to thank BambuLab for sending this machine for us to review. As always, we won't hold back from pointing out any issues or drawbacks we encounter during our testing. I would also like to thank VOXELPLA for sponsoring today's video. VOXELPLA is a US-based filament manufacturer that tests its materials in a 250 machine print farm running 24/7 to ensure consistent reliability and quality. VOXELPLA Plus is a modified PLA designed for higher impact strength, supporting high-speed printing up to 500 millimeters per second, while maintaining a flow rate of up to 25 cubic millimeters per second at a standard printing temperature of 210 degrees Celsius. All of their filaments, including PLA Plus and PETG Plus, are made in the USA and optimized for high-speed printing at an affordable price of $16.99 per roll. For print farms and other bulk orders, they offer additional discounts. They also manufacture 3D printing accessories such as filters, anti-vibration feet, and upgrades for BambuLab, Prusa, Creality, and Snapmaker printers. You will see more details about the VentoBox 2-stage filter, as well as how to use their cobalt-free silica gel drying beads to keep your filament dry in my upcoming videos. For the first 100 customers, you will receive 10% off orders over $100. Visit VOXELPLA.com. The A2l Combo came in a large box. Everything was packed neatly inside with thick foam for protection. The base, bed, and gantry require some assembly. There are also several accessories included, such as a spool holder, which I may not use since I will connect the AMS Lite to the machine instead. We also have the nozzle wiper, power cord, screws, tools, and a cap to cover the cable connector on the base. There are also some long bowed-in tubes for connecting the AMS to the print head. First, I will place the bed on the base and secure it with 4 screws. Then, the base needs to slide into the frame at an angle before being laid flat. After that, we can open the cover on the base and tighten the screws. All the screw holes are marked in green. This is also a good time to lubricate the Y-axis before closing the cover. Then, we need to connect one stepper motor cable inside the base and close the cap. There is another cable running from the base to the gantry. These 2 plastic blocks also need to be removed as they lock the gantry during shipping. Then we can mount the nozzle wiper. You can see there is an extra wire compared to the one on the A1. It is supposed to detect nozzle clumping. Just connect the cable and snap it in place. For the AMS Lite, I will put it on the side for now. I found that this cabinet, with a width of 32 inches or 800 millimeters, can fit the whole setup pretty well. Later in the video, I will also try mounting the AMS Lite on top, just like I did with my A1. Now we can turn on the machine. It starts with language selection, followed by location selection. Then you can connect to your Wi-Fi network, but it seems to only support 2.4 gigahertz Wi-Fi. After entering the password, it will connect to your network. You also have the option to connect to the phone app and cloud service, but I will skip that for now and use it within my own network. However, you do not have an option to disagree with the terms. You only have the option to skip the user experience improvement program. Then, it reminds you to remove the gantry blockers and lubricate the Y-axis, which I already did. After that, it starts the self-calibration process, which takes over 40 minutes. It starts with motor noise cancellation. Followed by input shaping. It calibrates input shaping at multiple positions, so it should deliver better print quality for tall prints. We will test that out later. Finally, it moves on to bed leveling. The auto bed leveling process is done in 2 rounds. That is also why the full initial calibration process took over 40 minutes. Okay, we are ready to start our first print. Let's load one spool and start with a simple preloaded G-code file to make sure everything is working. I will print this small cable clip that holds the bowed-in tubes and the cable on the print head. The default G-code sets the nozzle to 220 degrees Celsius and the bed to 55 degrees Celsius. I am not a big fan of setting the bed to this temperature, especially for smaller prints. Unfortunately, it did not stick well, so I restarted the print and set the bed temperature to 65 degrees Celsius. This time the print was successful and finished in 12 minutes. It is just a small print, but everything seems to be working normally. I will now move on to some color benchmark prints. I will start with the 4-color square. This small 5mm tall print uses all 4 colors on every single layer. This print is mainly used to test the filament changing speed. It will perform 75 color changes, and the estimated print time is 2 hours, which seems slightly faster than any single extruder AMS setup, but let's see if that's really the case. I will record the time required for different color changes. Watch the extruder wheel, and you will see the filament retract quite a bit before it is cut off, so there is less filament left inside the nozzle that needs to be purged out. From white to skin, it took 58 seconds. From skin to gold, it took a similar amount of time at 1 minute 2 seconds. From gold to white, it took a bit longer at 1 minute 5 seconds. From skin to blue, it took 1 minute 3 seconds. Finally, from blue to white, I expected this to take longer since it is a dark to light color change. It took 1 minute 25 seconds, so most color changes took around 1 minute. For dark to light changes that require more purging, it can take as long as 1.5 minutes. Overall, it seems the A2l's filament changing speed is faster than any single nozzle AMS setup. The print finally finished in 2 hours, which is surprisingly fast for a single nozzle AMS setup. The purge waste is 26 grams, which is about 4 grams more than the slicer estimate. The model is 5 grams, and the prime tower is 4 grams, both of which are in line with the estimate. Let's compare the result with other printers. Before testing the A2l, the most efficient bed slingers in terms of filament waste and print time were the original A1 and the Creality Spark X i7. Compared with both the original A1 and the latest i7, the A2l still has a slight advantage in filament waste. In terms of speed, the A2l also prints 22% faster than the A1 and 10% faster than the Spark X i7. Even when compared with the dual extruder X2D, it is about 18% slower. Since the dual extruder can eliminate some filament changes required by a single nozzle setup, it also produces less purge waste, resulting in a faster total print time. A tool changer like the FlashForge Creator 5 is obviously more efficient than an AMS-style setup in terms of both filament waste and time. But the A2l seems faster than any single nozzle AMS setup I have tested so far. I will do more color prints and see if it can consistently outperform other similar setups as well. I will expand my Hello Kitty army by printing 4 of them. When the print was about 80% done, the prime tower didn't stick well to the bed. But since I am printing 4 of the same item, I decided to let one sacrifice itself as the prime tower, so all the spaghetti and nozzle wiping would happen on this poor kitty. Still, it was better than restarting the whole print. The result is better than I expected. The spaghetti was quite easy to remove, and only a few pieces needed to be cut off with a flush cutter. The purge waste is 124 grams, the model is 200 grams. And the prime tower is 21 grams. However, I will add a few grams because I couldn't collect every single piece of spaghetti to rebuild the tower, so let's say it is 25 grams. Besides the one used as the prime tower, which has some minor imperfections, all the other kitties were printed very well. Let's compare the result with other printers. In terms of purge waste, the A2l and the Spark Xi7 are doing a better job than other AMS variants. However, the A2l is once again faster than any other AMS variant in this test as well. Compared to the dual extruder X2D, the X2D did save a lot of purge waste, and its printing time was also 18% faster. The H2C and tool changers like the Snapmaker U1 once again have a clear advantage over any single or dual nozzle AMS setup. Then, we will see how Vegeta, the Prince of Cyans and the King of Contamination, is printed on this A2l. The print finished in 7 hours 44 minutes, which is also faster than average. The purge waste is 131 grams, the model is just 16 grams, and the prime tower is 26 grams. The model was printed pretty well. Even when zooming in close, there is no color contamination. When compared with the Creality K2 Pro and FlashForge AD5X, the purge waste is once again similar, but the AD5X has clear color contamination with the slicer default settings. The K2 Pro by default is purging more than the AD5X, so it was also printed beautifully without contamination. In terms of time, the A2l is 18% faster than the K2 Pro and about 10% faster than the AD5X. When compared to the X2D, since this Vegeta model has a large portion of blue, which can be loaded on the second extruder, the dual extruder setup shows a bigger advantage in terms of both purge waste and print time. The next color print is the Master Sword. This model has almost 900 color changes, and I use it to test the reliability of the color changing mechanism. This model would take 32 to 50 hours on other single nozzle AMS setups. The slicer estimate is about 28.5 hours. I used the same green, blue, white, and yellow G-code file, but I loaded different colors into the AMS to make a Hello Kitty version. However, the purge volume still follows the original slicer colors. The print finished in 28 hours, 23 minutes, about 12% faster than the fastest AMS setup I had tested before. The purge waste is almost 600 grams, the model itself is about 100 grams, and the prime tower is about 50 grams. In terms of the result for this model, the current best performing single nozzle AMS style machine is the FlashForge 85X. The filament usage of both machines is similar, but the A2l is about 10% faster. Compared to the dual nozzle X2D, since this model also has a large portion of white, the dual nozzle switching saves a lot of time compared to changing colors with a single nozzle. As a result, the X2D is 2 times faster and also saves 8 times the purge waste. Of course, a tool changer like the Snapmaker U1 is more efficient than anything else in terms of both filament usage and print time. I will now run my single filament benchmark test prints. I will print 3 of them at the same time using by-object mode, as this 330 by 320 mm print area is large enough for multiple models, starting with the number slider, which is used to test clearance. A few years ago, machines from a $200 Basic Ender 3 to the $5,000 Ultimaker S3 couldn't print this model well without a lot of slicer tweaking. But these days, most new generation printers can handle this model well. Next is the tolerance test, which tests whether 2 objects can fit together. Finally, the mini honeycomb box. The honeycomb pattern is tiny, and the extruder needs to extrude a small amount of filament, retract right away, and move to the next spot. Let's take a look at the number slider. It finished in 2 hours 44 minutes, in line with the average time of about 2 hours 45 minutes. The top printed okay, with no stringing at all. The bottom printed beautifully and stuck to the bed very well. All tiles can move freely. For the tolerance test, it finished in 1 hour 24 minutes, a little faster than the 1 hour 30 minutes average time. On the square side, it clears up to 0.05 millimeters and stops at 0. On the cylinder side, it also clears up to 0.05 millimeters and stops at 0, so it achieves a perfect score. For the honeycomb box, the patterns are clear and there is almost no stringing. When compared to other good quality printers, the A2l performs in line with them. I will also print the Robo Alpaka with tricolor silk PLA to test the surface quality. The print finished in 4 hours 27 minutes. The speed is also in line with the average speed among all new generation machines, but the surface quality looks good. Compared to the Chitty Max 4, which is considered to have pretty good surface quality, the A2l is actually not far from it, and the print time is also identical. Compared to the H2C has slightly better surface quality and is much faster. Compared to the X2D actually has better surface quality and also much faster. Compared to the Snapmaker U1, the U1 has better surface quality and is also much faster. Compared to the Prusa Core 1, the print times are similar, but the A2l has better surface quality. Compared to another bed slinger, the Creality Spark Xi7, the A2l prints faster and also has better surface quality. I will also print a PLA sheet to test the auto bed leveling and auto Z offset. The sheet can be peeled off in one piece without line separation. It's pretty much a perfect first layer, and it should be more than enough for any print. Since the table space required for the A2l and the AMS Lite is 32 inches wide, I would like to print a top mount for the AMS, as I also did that for my A1 and A1 Mini. I will use PETG to print the model and PLA as the support interface. This way, it only has 19 color changes and wastes a minimal amount of filament and print time. The estimated time is 6 hours 14 minutes. The print finally finished in 6 hours 13 minutes. The PLA support interface makes the support material extremely easy to remove, and the surface of the model is super clean. The printer also came with some longer screws for use with a top mount. Even though the mount I printed was designed for the A1, it works pretty well on the A2l as well. The only problem is that I cannot put it in the center because the AMS Lite cable is not long enough. I have to mount it on the right side so the cable can run through the back of the machine and reach the connector. Since the input shaper calibration on this printer is done at multiple positions, I believe it should improve taller prints. I will print a tall trash can at 325 millimeters to max out the Z height. This print finished in 8 hours 21 minutes. From a distance, the top part of the model doesn't look too different compared to the bottom. When zooming in, the top also doesn't look too different from the bottom, which is totally unexpected. For reference, I had another slightly taller trash can printed on a tall bed slinger, and I think the difference is obvious. The multiple point input shaper calibration really made a difference. I also tried printing with TPU. I used BambuLab 90 ATPU to print a simple card wallet. For 90 ATPU, the volumetric speed is only set to 2.8 cubic millimeters per second, so the actual print speed is very slow, around 35 millimeters per second. It also cannot feed through the AMS, so I used the spool holder and removed one Bowden tube to feed the filament directly to the print head. Compared to the coupler on the A1, the A2l makes the tubes much easier to remove. The print finished in 1 hour and 13 minutes. The extrusion was pretty smooth, and the print looked all right. 90 ATPU is much softer than regular 95 ATPU, but when feeding it directly to the print head, it worked just fine. Finally, BambuLab also sent me a set of pen and blade cutter modules. It also includes a cutting mat to replace the print bed. For the module, you just need to open the print head cover, remove the dial, and snap it onto the print head. Once the module is installed, it will perform bed leveling using the blade. For the software, it uses Bambu Suite. You can simply import an SVG or use the basic tools, then select the operation you need and start the job. I will simply cut out some letters from this copy paper. Of course, it can also be used for stickers, vinyl, or thin leather. You can also change it to drawing mode. You can see the pen probing on the middle right of the paper, as that is the starting point. If I wanted to probe another spot, the software allows me to select a target instead of probing the starting point of the drawing. But since this is just a simple demonstration, I will let it finish. These pen and blade modules are not super useful to me, but they may be useful for some users. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The machine has a very rigid build. Even though the gantry is tall, the support arms are very sturdy. For a bed slinger, the heavy base also makes it feel much more stable than most machines in this category. Another interesting detail is the 2 granular dampers installed on the top frame to help dissipate vibration. It is a small but very unique design choice that I have never seen on a 3D printer before. 2. The filament change speed is faster than any single nozzle AMS setup I've tested. Most changes take about 1 minute, while dark to light changes can take up to 1.5 minutes. After more than 2,000 color changes, I didn't see any take longer than 1.5 minutes, making it faster in every multicolor print I tested. 3. The print head buffer has been redesigned. It now retracts the filament more aggressively before cutting it, leaving less molten filament inside the nozzle. This significantly reduces the purge volume. In my tests, it saved up to 50% of purge compared to some setups, and still saved around 20% compared to other newer setups. You can potentially save even more by enabling the long retraction when cut option in the slicer's developer mode. This option has actually been available for about 2 years, and you can also use it on the older A1 and A1 Mini to reduce purging. 4. The multiple point input shaper calibration does make a noticeable difference. When printing a tall model that nearly maxes out the Z height, the surface quality near the top is almost the same as the bottom. Compared to other machines that only calibrate input shaping at one fixed height, the difference is night and day. 5. This is a well-polished consumer-grade 3D printer. In terms of fine details, I don't think anyone does it as well as BambuLab. The setup wizard is not just one of the best, it is the best I have seen on any printer I've tested. Every step has a clear progress bar, and during input shaper calibration, it even shows the frequency in real time. Many other brands simply show a "please wait" screen for 10 minutes. There are no sharp corners, and everything from the software to the hardware feels refined and thoughtfully designed. Now for the cons. 1. There are still a few things I don't like about the AMS Lite, and they have not changed since the original A1 or even with this new A2l. The first is the spring-loaded spool holders. They work with most filament spools, but since there is no standard spool hole size, some filaments do not fit well. For example, Prusa filament barely fits, while some spools with larger center holes will not fit properly unless you make adapters yourself. The second is how the filament is parked after a print finishes. The AMS Lite only retracts the filament a little, leaving about 2 to 3 feet long filament inside the Bowden tube. If you do not print that filament for a week or 2, especially with more brittle filaments, it may break into several pieces inside the tube, and then you have to push it out manually. I think it would be better if the system retracted the filament almost all the way back, leaving only about an inch inside the tube. That way, the filament would not stay bent inside a curved Bowden tube for weeks, making it much less likely to break. 2. As a mid-size bed slinger, it takes up quite a bit of space. If you use the AMS Lite with the stock stand, the entire setup can occupy nearly all of a standard desk. You can mount the AMS Lite on top to reduce the footprint, but the trade-off is that it requires more than 1.1 meters of vertical clearance. So, if desk space is a major concern, you may be better off with a Core XY machine that offers a similar build volume in a more compact footprint. 3. For people who value open systems, Clipper-style flexibility, or full control over their machines, BambuLab controversy around third-party compatibility is also a drawback. Recently, Bambu restricted a fork of Orca Slicer from accessing its cloud service, and some users were not happy about that. Personally, I also like Orca Slicer, and I try to use it as much as possible instead of installing dozens of skin slicers from different brands on my computer. That said, for BambuLab and Prusa machines, I always use their official slicers. In my opinion, these are the only 2 brand-provided slicers that are actually worth installing, because they provide a truly optimized experience on their own printers. At the end of the day, Orca Slicer is based on Bambu Studio, and Bambu Studio is based on Prusa Slicer, so I don't really see the need to replace either of them with Orca Slicer. In conclusion, in terms of hardware and software, I think no one else can make a single nozzle AMS setup better than BambuLab. However, buyers will always compare it with other options available in the same price range. If we break down the current offerings on the market for standard size bed slinger AMS or AMS clone setups, we have the Anycubic Cobra X, priced at $279. Of course, it may not perform as well as the A2l, but it's much cheaper and still a pretty usable option for someone who wants to start multiple color 3D printing. If you pay $90 more, at $369, you get the Creality Spark X i7, which comes with a fully enclosed filament box and a slightly more refined machine than the Cobra X. For another $30, you can get the original A1 combo at $399. As the A2l is basically a larger A1 with a few meaningful upgrades, the $569 price tag, which is $170 more, still feels reasonable. However, once the price gets close to $600, buyers have more options to consider. For example, the FlashForge Creator 5 is a Core XY tool changer that is regularly on sale for $699. That means for only $130 more, you can step up to a Core XY tool changing system, even though it has a smaller print volume. I have also tested the Creator 5 a few weeks ago. It's not as refined as BambuLab machines, but at the end of the day, it is still a tool changer. For multicolor printing, it is not just a little faster, it is much faster, and it produces almost no purge waste. A little over $100 price difference can put the A2l in a difficult position. Not because the A2l is not good enough, but because another machine with a completely different mechanism, one that is better suited for multicolor printing, is available for only $130 more. That makes the buying decision much harder. In just a few years, BambuLab went from being a newcomer to becoming the most dominant name in consumer 3D printing. However, I think this is an extremely critical moment for BambuLab. They need to choose whether they will continue going all in on AMS-style systems or eventually release a tool changer model. I think the market response is clear. Last year's Snapmaker Z1 Kickstarter campaign attracted over 20,000 backers and raised more than $20 million. That's solid proof of what the market wants. The current biggest limitation of tool changers is that you cannot print with more filaments than the number of tool heads, which is usually limited to 4 or 5 in most cases. With BambuLab's R&D capability, if they really want to enter the tool changer market, I wouldn't be surprised to see them release some kind of hybrid system that combines the strengths of a tool changer and AMS. If that happens, I believe they could once again take over the market in the blink of an eye. In terms of value, I don't think the A2l is a super competitive product in the current market. However, among AMS-style bed slingers, and even compared to other brands' AMS clone Core XY machines, none of them perform better than the A2l in terms of filament saving and print time. So, I will still add it to my recommendation list at AuroraTechChannel.com as the most advanced mid-size bed slinger. If you are interested in the A2l, I will put the link in the video description. Don't forget to also check out AuroraTechChannel.com, which monitors prices for popular 3D printers, laser engravers, and CNC machines to help you find the best deals. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.